All right, let's try practice 2A again, solving absolute value equations, this time with sound. All right, first one. So we're looking at our back of your notes. Take a look at those. Make sure you know them. The steps. We have isolating the absolute values. So this absolute value has to be all by itself on one side of the equal sign. It is. So once it's isolated, I should also stop us and think, is the opposite the other side of the equal sign, is that a positive number? Yes. So we're going to keep solving. If it was negative, we would just say no solution right now. But it is positive, so we're going to keep solving. You have two sides to the absolute value. Two numbers are 9 away from 0, I guess we should say. So it's 9 is 9 away from 0, and negative 9 on the number line is 9 away from 0. So we need to solve both of these equations. Solving both. One-step equations. X equals 12. That's a potential solution. We don't know if it's an actual. I should have canceled that out, cross that out. We don't actually know if these are actual solutions until we check them. So let's check quick. So a quick check. You can do this in Desmos. I'm going to go back to the original problem. Always the original before you do any math, any kind of operations. 12 minus 3, does that equal 9? 12 minus 3 is 9. The absolute value of 9 is 9, so that's good. So 12 is an answer. And let's substitute in negative 6 into the original problem. Negative 6 minus 3 is negative 9. The absolute value of negative 9 is 9. 9 does equal 9. Good. Therefore, that is the solution. Perfect. Moving on to number 2. Isolate the absolute value. Boom. It's isolated already. That's awesome. Once we get that isolated, we have to check, is the right side, the opposite side of the absolute value, is that positive? No, it's negative. And on the notes, anytime you think absolute value, anytime the absolute value, you always got to think absolute value, the number that always comes out of it, no matter what, is always positive. Well, then how can it possibly equal a negative number? Well, it can't. So this is a special case, and we just say there's going to be absolutely no solution to it. That's why it's special. It has no solution. Working on number 3. Just going to give myself some room here. Number 3, we have, so it's a little bit different, but there's the absolute value. Is it isolated on one side of the equal sign? There's no add, subtract, multiply, divide? Nope. So we got to keep moving on. So typically we'd look on the opposite side of the absolute value and be like, is that a positive or a negative number? Well, we don't know. It's an expression. An expression, we don't know what value we're going to put in for x. What value is going to be x? We have no clue. So we're just going to assume that it's going to be a positive x. So we're going to assume the right side is going to be positive. And we're going to continue to solve this problem, just like we did up top. There's always two sides to, unless it equals 0, always two sides to every absolute value problem. We're going to say that this first side is the positive side. And what if it wasn't positive? Well, we do have to solve for that too. So I shouldn't say we assume it's positive. We're just going to assume that it potentially could be a positive. Assume potential positive. So we're going to also, the second equation we're going to write is, what if it's negative? Or if it comes out to be the negative side? I guess I should probably say that the absolute value, like I said in the first one, there are two distances from 9. Well, there's two distances to 0 from 5x plus 2. There's a positive 5x plus 2 and a negative 5x plus 2. That's probably a better way of saying that. Now we need to solve both of these equations. It doesn't matter how you do it. Get your like terms together. 5 comes down. 2x plus 2 minus 2 minus 2. 3 equals 2x. So x is going to equal 3 over 2. That's a potential answer. Then we have to distribute this negative in. You can think of it like a negative 1. Negative 5x minus 2. Get your like terms together, the x's. You can do this and the next step in the same step if you wanted. minus 5, minus 5, negative 7, divide by 8, divide by 8, negative 7/8. We do need to check these on Desmos or here. I don't have Desmos with me, so I'm just gonna, right now I'm just gonna keep writing below. So we have 3 times 3 over 2. I'm gonna check, let me stop here. I'm checking, let me slow down. Get a little excited sometimes. The check is gonna be with the original problem, always the original problem. Before we did any work, when we first looked at the problem, that's where we're gonna start. So we're gonna substitute in x equals 3 over 2 into each x. 3 times 3 over 2 equals 5 times 3 over 2 plus 2. Let's see if this left side equals the right side. So that's 9 over 2 plus 5 equals 5 times 15 over 1 times 2 is 2. 9 halves and 5 is, we have 9 over 2 plus 10 over 2, that's 5, so that's going to be 19 over 2. And on the right side we have 15, this is going to equal 15 over 2 plus 4 over 2, which is 19 over 2. Probably a lot easier on Desmos, but 3 over 2 works, that's great. Let's also check x equals negative 7/8. 3 times 7/8 plus 5, close, what did I just do? Parentheses there, I don't need the other parentheses. Equals 5 times negative 7/8 plus 2. All right, let's clean this up a little. 3 over 1, so that's negative 21 over 8 plus 5 equals 5 times negative 7 is negative 35 over 8 plus 2. Like I said, Desmos is going to probably be easier. I don't really need to see this work. I'd rather see all the other work and have Desmos. I just don't have Desmos right here available to me. 5 with a denominator of 8 is going to be converted to 40 over 8. 2 with the denominator of 8, you unreduce that, or what divided by 8 is 2, that's 16. So we have on the left side, that's going to be a 19 over 8. And does that equal a negative 19 over 8? No, the absolute value of 19/8 is 19/8. And that does not equal negative 19/8. So that is no good. Cross that out, or you could say that's extraneous. So the only answer is 3 over 2. All right, let's keep working. Number 4. All right, back to a little bit less complicated problem probably. Isolate the absolute value. This is the first time we're going to have to do this on these problems. The 10 is on the outside of the absolute value. It's on the same side of the equation now, or the equal sign. So we move it. It's a positive 10, so we subtract 10. Now the absolute value is isolated. So now we're going to look at the opposite side of the absolute value. Is that a negative number? If it is, like number 2, then we stop and say it's no solution. Well, 15 is positive, so it's not negative, so let's keep moving. We're going to split it up into 2 problems. So taking the whole equation and splitting it up into 2 problems. Oh, forgot the negative. Because there's two distances from 0, that's 15. It's positive 15 and negative 15. Solve both. X equals 16 over 3. X equals negative 14 over 3. Both are potential solutions. We don't actually know, though, so we got to check them. So let's check. I have, let's go back to the original problem. We're going to use that. I'm going to put in 16/3 first in for x. Replace the x with 16/3. Minus 1 plus 10 equals 25. All right, cool thing about this, you could do 3 times 16 divided by 3 and that will work. But you have 1 multiplication times 3 and 1 divided by 3, so those will cancel out. You get 16 minus 1 inside the absolute value plus 10 equals 25. 16 minus 1 is 15. And absolute value of 15 is 15 plus 10 is 25. Cool, that works. So 16/3 works. Let's check the other one. Negative 14/3, let's check that out. 3 times negative 14/3 minus 1. Again, I'd use Desmos on this if you'd like. Cancels out. Negative 14 minus 1 plus 10 equals 25. Negative 14 minus 1 is a negative 15. And you're thinking negative, but absolute value of negative 15 makes it positive 15. And now it's looking good. 15 plus 10 is 25 equals 25. Awesome. So that is a good answer also. All right, moving on. Number 5. So this is the first problem where you actually have an expression on the right side and we don't have the absolute value isolated. You have a times 2 on the outside. So let's divide by 2, divide by 2. You have 3x minus 7 equals, you gotta think of it this way, 10x divided by 2. Usually you're dividing each term by 2. That's 5x. And 8 divided by 2 is 4. Oh, forgot the absolute value, my bad. At this point, the right side is an expression. We don't know if it's positive or negative, so we're just gonna keep moving on with the problem. 5x minus 4 is going to be 2 distances from 0. There's a positive distance and a negative distance. So we're going to break this up into 3x minus 7 equals 5x minus 4. So we're going to just assume that's the positive distance. And then the negative distance is here, the negative distance of 5x minus 4. We don't know what the actual distance is. I'm just saying distance because that's what we were saying before. Solving each problem, get your like terms together, your variables. Minus becomes a negative. Add 4 now to get your constant terms on one side. Divide by 2 to get your variable isolated or alone. So a potential solution is negative 3 over 2. Keep saying potential because we don't know until we actually check. Distribute in the negative. Think of it as a negative 1 if you need. Negative 4 times negative 1 is positive 4. Now gather your like terms, the x's. Divide by 8 to isolate the variable, get the x by itself. And another potential answer is 11/8. Again, I would probably do this in Desmos, but we do need to check both of these. Use the very original problem. So we're going to check using the original problem. So it's 2 times 3. I'm going to check 3 over 2 first. 3 over 2, negative 3 over 2 minus 7 equals 10 times negative 3 over 2 minus 8. So I'm just going to simplify each side separately. So it's 2 times the absolute value of 3 times the negative 3 over 2 is a negative 9 over 2 minus 7. On the right side, it's 10 times negative 3 over 2, so negative 30. Multiply the numerators, multiply the denominators. Still got more work to do with combining numbers. And so we have 2, it's 9, negative 9 over 2. We got to make the denominator 2, so that's 14 over 2. Those of you that are working it out like this, it's awesome. But if you'd really just dread this, go use Desmos. Not a problem. I have nothing wrong with that. -9, now we have like denominators, so we can subtract. -9 minus 14 is -23 over 2. And on the right side, we have -46 over 2. So if we keep working on this, which I can, absolute value of -23 over 2 is 23 over 2. We still have times 2. You should be able to see already, when we multiply these two together, it's going to be 46 over 2, which does not equal -46 over 2. So that doesn't work. You can cross it out, or you could just say it's extraneous. All right, now we got to do this for 11/8. Feel like I'm running out of power. A lot of work. Desmos would be a lot easier, but those of you that are staying with me, awesome. Much appreciated. So let's check 11/8. So 2 times 3 over 11/8 minus 7 equals 10 over 11/8 or times 11/8 minus 8. All right, let's think of our math. Our rules. So we have like multiplying fractions, multiply the numerators, multiply the denominators, multiply the numerators, 110 over 8. Whew, that's going to be a big number. All right, now we have subtracting fractions, so you need to get like denominators. So I need 8 as a denominator, so that's 56 over 8. On the right side, I still need 8 as a denominator, so that's 64 over 8. That'll get you like denominators there. 33 minus 56 is 23, -23 over 8. Over on the right side, it is 36. So subtract your numerators, keep your denominators, 36 over 8. No, 46, Mr. Johnson, 46, my bad. On the left side, take the absolute value of -23 is 23, so it's 2 times 23 over 8. And does that equal 46 over 8? Yeah, sure it does. 46/8 on the left, 46/8 on the right, and we're good. That is a good answer. Whew, a lot of work, but we did it. Good job. Thanks for staying with me. Last problem, number 6. All right, same as last problem. You have a times 6 here, so we need to divide. You're dividing each term by 6. 6x divided by 6 is 1x. 1 times x is just x. You could write 1x too, it's fine. 24 divided by 6 is 4. We're assuming we're just going to keep moving on as if x is positive. So we are going to break this up into 2 problems, 2x plus 5, x plus 4. So you can write it down exactly how you see it. Remember this distance from 0. So that's x plus 4 from 0. We don't know what x is. But we also have a negative distance from 0. And so we have both the positive distance and negative distance on the left and right. Solve both of these problems. 2x minus x is x, or 1x. Oh, we might actually get a whole number or an integer. An integer. -1 is a possible answer. Let's distribute in the -1 on the right side. Get your like terms together. And another integer. Cool. All right, we do have to check these. Let's check them. This one might be a little bit easier, I'm hoping. I don't even like fractions. I work with them, but still. So let's check with the original problem before we divide it by 6. 6 is on the outside. 2 times, I'm going to substitute in -1 right away. Plus 5 equals 6 times negative 1 plus 24. All right, simplify each side as if it's like its own simplification. So 6 is on the outside, 2 times negative 1 is negative 2. So all I was doing is just simplifying. I just did one step. 6 times negative 1 is negative 6. I don't like to do more than one step at a time. It's pretty easy to write things down. Negative 2 plus 5 is 3. Negative 6 plus 24 is 18. Absolute value of 3 is 3. And the 6 times 3, 18. Yep. 18 equals 18. So that's a good answer. Negative 1's good. Let's check. So this was a checking x equals negative 1. Let's check x equals negative 3. So we have the original problem again. 2 times negative 3 plus 5 equals 6 times negative 3 plus 24. So one step at a time. 2 times negative 3. So I'm doing Pemdas, parentheses, exponents. So treat the absolute values like those are parentheses. Inside of that, you start order of operations over, so multiplication. On the right side, order of operations, there's only multiplication and plus, so we multiply first. And we would add next, but I'll get there. On the left side, negative 6 plus 5, so inside the absolute value, we need to do that, is negative 1. On the right side, we have negative 18 plus 24 is 6. So we have 6 times the absolute value of negative 1. Absolute value of negative 1 is 1. Does that equal 6? Yep, 6 equals 6. Awesome. Both are answers. Cool. All right, so that's 2A.